And the latest addition to the family here is conditional types, which allows us to express non-uniform type mappings. And I'll give you some examples here. Let's say I have 3 types, name, ID, and check. And let's say that they represent labels that I want to put in my UI. I have a certain kind of UI element that's called name that I use for strings, and IDs I use for numbers, and checks I use for Boolean values, right? Now let's say I want to write a function that takes some value and creates the label that corresponds to that value. Well, now I would have to write a whole bunch of overloads. I'm sure some of you have written overloads like this where, hey, if you give me a string, then you get back a name, and if you give me a number, you get back an ID, and if you give me a Boolean, you get a check. But then, of course, you might give me something that is string or number or Boolean, in which case you get one of the others. In fact, it's not even complete here, because you might give me just string or number, in which case you should only get name or ID back and not check, because it couldn't be that, right? And so you see how this can very quickly get unwieldy to try to write a whole bunch of overloads. And really what you want is sort of the ability instead to express it in the type system more directly. And that is what conditional types enable you to do. So here we can declare a label for type. So I give you a T, and then when T extends string, I want you to give me back name. And when T extends number, I want to get ID, and when T extends Boolean, I want to get check. Otherwise, this should never happen, is what this type says. And now I can declare create label as just, it takes some T, that is a string or number or Boolean, and then it gets back a label type that corresponds to that type, right? And now, it's just sort of, I don't have to write overloads, it just comes out of the types, if you will, right? That if I give you Joe, you get a name and blah, blah, blah. But if I give you, say, Joe or 42, well, then that's a string or number, so you're going to get a name or ID back, right? Because we understand how the types flow. And in fact, we will spread union types over, we will distribute union types over these conditional types. So that last, the D and E examples are interesting because the type that goes in, that we infer in, is number or string. And then we apply that to each of number and string and produce a resulting union type out. So if you give us a union type in, a union type comes out that has been mapped for each individual element. So this cleverness you can use, we can use to create interesting types, like a thing that reduces a union type or extracts stuff from a union type. So for example, here, if I have a string or number or some function type, and I exclude function, then I get just string or number, or if I extract function, then I get only the function parts of it. But now I can make a non-nullable of T that gets rid of null and undefined from some T, and that's actually quite useful. Also, we support the ability in conditional types to infer constituent types. So say I want to write a flatten or a smoosh of T operator. And this one says, if you give me an array, then please infer the element type of the array and give me that back. Otherwise, just give me back the type that I gave you. And now, flatten of string is just a string, but flatten of number array is a number. And so you can actually do some interesting reaching into types. And this turns out to be very useful for creating a very wanted type operator called return type. Say I have some function type, I want now to get the return type of that function type. Well, you can create a conditional type that reaches in and gives you that. It's useful, like, let's say I have written some function that returns some complicated object literal. Well, return type of foo will give you back that type. And in fact, we can now build all of these into lib.d.ts, the predefined types. We already have partial read-only and pick and record that some of you may have seen. But now in Typescript 2.8, we've added exclude and extract, non-nullable, return type, instance type, and so forth. Okay, so that's a lot